Hi, everybody. This is Mr. Folly, and welcome to podcast 5.2. We're talking about percent composition, empirical formulas like the Empire, and finding molecular formulas. Hopefully, my screen won't keep switching like that. So let's hop into it. Percent composition is just like the last chapter. It's a ratio of part over total. So for magnesium, it's going to be Mg over MgCl2. So if you go to your periodic table, oh, this is going to be a bad one. It's going to be 24.31 over. I'm going to add up magnesium, 24.31 plus 2 chlorines. There's 2 chlorines. Each chlorine is 35.45. So the total is 95.21. So when I do 24.31 divided by 95.21, I get, don't forget the times 100%, I get 25.5% Mg. And then the chlorine is going to be 2. Chlorine is going to be Cl2 over MgCl2. So that means it's going to be 2 chlorines are 70.90. Oh my goodness. Over the total, which is 95.21, which is going to be, I think maybe I should try and use the force to figure out where these numbers went. Concentrate. Hopefully you can see it and rewind it and it'll show up. Sulfur difluoride is 54.2 grams of fluorine and 45.8 grams of sulfur. Find the percent composition. So if I want to do fluorine, I'm going to have F over, what is it, SF? No, get back here. So for fluorine, it's going to be F over SF. Okay? So fluorine is going to be F over SF, which is going to be 54.2 over the total. Add those two together. 54.2 plus 45.8, which is 100. Oh, that makes it easy enough, which is 54.2%. S is going to be then S over SF, which is going to be 45.8. It's going to be 45.8 over 100, which is 45.8%. All right. Let's hope. Take a deep breath. Let's hope these guys are going to work for us. Empirical formulas. Okay, empirical formulas are entirely new. So this tells us, how do I figure out that there's a 2 in H2O? And how do I know if I'm CO or CO2? So these numbers down here are really moles. That 1 is also a mole. Okay, so we're going to turn grams into moles, turn moles into whole numbers. So we're going to find, oops, come on, least common. We're just gonna unfraction them, and then those whole numbers are turned to subscripts. So let me show you what I mean. 1.6 grams of H, and it's stacked up like this. I'm going to have 22.2 grams of N. I'm going to have 76.2 grams of O. Please. So now what I'm going to do is convert each one into moles. So I go to the periodic table and get these numbers. And that grams, again, comes from the periodic table. Oh, no, I put it in the wrong spot. And now I'm going to have issues because I'm going to try and erase something, and we all know that's not going to go well. No. Okay, well, we'll go back to the pen on this. So I guess I have to do 14.01 grams of N, 1 mole of N. And then I'm going to have 1 mole of O and 16 grams of O. Let's see. 1.6 divided by 1.01 is 1.584. And then 22.2 divided by 14.01 is 1.584. Hey, that's the same number. That's coming. And 76.2 divided by 16 is 4.725. So now what I'm going to try and do is get these things into whole numbers. So to get them into whole numbers, I'm going to divide by the smallest. So unfraction them, divide by smallest. So my smallest number is 1.584. And I don't even need a calculator for that. 1.584 divided by 1.584 is 1. Now this, I'm hoping, is a whole number. 4.7625 divided by 1.584 is 3.00. So what that means is, now I've got these nice numbers. I've got H, 1H, so this is H, okay, 1N. Oh, you're kidding me. No way. Well, I had 1 for H, 1 for N, and O was 3. So that means my formula is going to be HNO3. The force is weak with this one, clearly. Oh, man, that's not supposed to be that. A sample of a compound is broken down into its constituent elements. You have 13 grams of lead, 1.77 grams of nitrogen, 4.03 grams of oxygen. What is the empirical formula? So hopefully this will go a little better. 13 grams of lead. And I'm going to have 1.77 grams of nitrogen and 4.03 grams of oxygen. And I'm going to go to moles. Always go to moles, always go to moles, always go to moles. Again, the numbers I'm getting are from the periodic table. So there's 14.01 on the periodic table. And there's 1 mole of oxygen equals 16 grams of oxygen. Hey, it's being nice. Maybe because I said the force was weak with me. So then I do this math, and I get 0.0627. 1.77 divided by 14.01 is 0.12633. And then 4.03 divided by 16 is 0.25188. So remember, I want to get these into whole numbers. So the next step is divide by smallest. That way my numbers will all be at least 1. Divided by 0.0627, divided by 0.0627, divided by 0.0627. That one, that one is 1. 0.12633 divided by 0.0627 is 2.01. 2.01 is 2. 0.25188 divided by 0.0627 is 4.01. That's 4. So what that means is I have PB1. Hey, that's 1. N2. Hey, that's 2 for N. And then O. Hey, 4 O's. 4. And that's it. Oh, and it moved on its own. So how about that? Empirical and molecular formula. Empirical is reduced. Molecular is exact. Molecular, this is the exact formula. Hey, look. I can reduce that. Divide both by 2. Hey, this is the exact formula. Uh-oh, I can't reduce it. Sometimes they're the same. Hey, how about that? Whoa. This one, N2O4, I can reduce that. Hey, I can reduce that. So the empirical is the reduced formula. Molecular is the exact. All right. If an empirical formula CH2 has a mass of 22.06, what's the molecular formula? So what I'm going to do is I'm going to find the mass of the empirical formula. The mass of CH2 is 12.01 plus 2.02 is 14.03. So 20, I messed that one up. I believe. So I'm at a big boo-boo. That's supposed to be 28.06. So 28.06 divided by 14.03 equals dose. Okay, so what that means is if I have CH2, I multiply it by 2, I'll get C2H4. That's my molecular formula. The sub says an empirical formula of no. The name is no. Number is no. And a molecular mass of 30.01. What is the molecular formula? So 14.01 plus 16 is, get back here, 30.01. Okay. If the molecular mass is 30.01 and the empirical, if molecular equals empirical, then same formula. Yeah, it is. So that means NO is NO. Empirical, dun, 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 equals more. And review. Always go through most for empirical and how many fit per molecule. So you're going to have that multiplier in it. Enjoy the Star Wars stuff. Toodles.